To stop. We talked about stop. Wait a minute. What? That's funny. Section 4.8, applications and models. We talked about how right triangle problems start to be applied to word problems, and that we're basically just using all the review stuff we've already done with right angles and applying it. So I think we probably did number 20. That probably wasn't a big deal. Hopefully, did we get through all of 25? He was a party waiting to happen. That's what was going on in number 25. Did we go any further than 25? Did we get to number 26? You think we did?
We did that.
We talked about bearings?
No,
Is 26 is where you stopped?
No, we got through the whole
thing. You did bearing too?
No, we didn't do bearing.
Okay, bearing is where we stopped. So we got through 25 and 26. Okay, let me double check really fast that at least you have the right perspective on number 25. I can go steal the notes from last year. I don't need to necessarily redo all these problems. I can steal the notes, even though the video, you guys were able to see it that Friday. If anybody was gone, you might have been like, what am I supposed to do? So I'll make sure to get those notes copied in so you can see these examples. But guys, what was the big idea on number 25? I think out of all of them, he was the hardest. I think this was a little weird. That was a little hard, but what we're supposed to be finding.
How far apart is
that, right? And where are my two triangles in the sky? Yeah, so I have my 55-degree angle or 55-degree triangle, right? And then I have my 20, is it 28? And then I have my 28-degree triangle. And what do we know about how high the airplane is, which would measure both of their opposite sides? 10 kilometers. And what can you do if you know two pieces of any right triangle? If it's two sides, we can solve for the third side with Pythagorean theorem. But what do you notice about one of my pieces of information? I know angle and side. I need trig, so Patoa, to find whatever I'm missing. Now, what's going to help me find x? Are the triangles drawn down to the ground? No. So where else is x? Isn't it right here? It's the distance overlapping of the green overlaps the red. It's how much beyond the red, the green. Wait, what sides are these guys? If that's opposite, who's this?
Adjacent.
Adjacent, because this is my right angle, right? And these are the hypotenuses that they are. So all we have to do is say, hey, what's your adjacent for the red? What's your adjacent for the green? And then subtract the two, and then we have our x, no big deal. So guys, what trig puts together angles and opposites and adjacents? TOA! All we had to do was a TOA to be what? X, no, 10, opposite, sorry, over my, I could do my little a, my red a. And I could do tangent of my 28 to be 10 over my green A. And with quick little solving, I can get my red adjacent, I can get my green adjacent. All I have to do for x is go ahead and subtract the two. Now in math, you don't usually just use different colors. You use like subscripts to make things a little bit different. But hopefully you guys watched me and solved through with me finding and have our A2 minus our A1. And then we're done. No big deal. Number 26 is a little bit harder, and I circled this thing called speed. Because it's speed, how fast the plane is going, not that kind, Alex. Is that something that we normally label a triangle?
No.
We label distance in a triangle, not how fast. So then when they told us the elevation of the plane was like 16 degrees.
Wait, is Misty,
huh?
Is that really how fast the plane?
Don't planes go faster than that? I thought planes go faster.
Well, if you check this out though, hold on. If it was 16 degrees here, and then it's 57 degrees later, what's the plane doing?
Going up.
Exactly. So theoretically, the plane's taking off. So I don't think it's reached its maximum.
That stalls right there.
Does that make sense?
Wait, what is it usually like?
Ask Joe Cowan. He would totally
Who?
know. Joe.
Joe, ask
Joe.
I
Joe.
love
He
Joe.
Ask
knows
Joe.
everything to do with planes. I'll ask him today in period 6.
How
I'll
fast
answer for
the
you.
plane goes?
How fast? What do you guys think? Like a 747?
1,000.
No, we're talking about like a
No.
Black Hawk.
No. A passenger plane. Oh, it doesn't say passenger plane.
It doesn't. So it could be like a military.
I'll get you a couple of them. Military and then
Thank
passenger.
Does he
you.
want to be a pilot?
He just knows those numbers.
He has like an uncle or something that has an aviation stuff back in China, and he's put in lots of flight hours.
Oh, that's
He
nice.
just knows a lot of stuff.
He's put in flight hours.
So he can fly planes.
That's kind of
Okay,
scary.
shh.
Okay, so.
Go talk to Joe.
We all have the badass.
Yeah.
Hey guys, do you notice there are 2 different triangles in this one too, though? Right? And what are they asking?
They're asking for an altitude.
They want to know how high the plane is after the minute. Did anybody notice that the 1 minute was important before I pointed it out last Friday? Because if you know, right? If you know how fast the plane is going, and you know how long it's taken, if you're going 60 miles per hour cruise control and you travel for an hour, how far have you gone?
1 mile.
Wait, say that again?
You're going 60. Your
Oh.
speedometer is at 60 miles
60
per
miles.
hour, and you travel for an hour.
60
You've
miles.
gone 60 miles. That's what it means. It takes
Oh.
1 hour to cover 60 miles, right? Depending on the road, it could be fast. Okay, coming back. If you were like on a scooter, it would be like. Anyway, coming back. I proved my point. Do we know anything about this plane?
Yes.
Besides the angles? We need sides. Like, we need sides to go with the angles. We don't know anything. Wait, what do we know?
We know 2 angles.
We have X.
No, we don't have X. That's what we're trying to find.
We have 90 degrees.
Well, we do have 90 degrees, and we have 16, and we have 57.
That means we can.
And we have you watching the plane, and the plane is here, and then the plane is
Well,
here.
we can add 57 and 90 and subtract
Set
by
the
80
equal
at the last angle.
It's a little bit weird to think about, but if you guys think about the triangles being the other direction, with a 16 here, which would also mean a 16 here, if you go back to geometry and parallel lines and all that. And then if you thought of the 57 guy as being here, which would also be here, you go in that way. Couldn't you figure out how far the plane has gone? Using this whole, like, hey, a minute later in miles per hour. You have to do a Mrs. Leon thing with the bridge. Because right now, because you gotta get rid of the hours to do a minute. But can't we get rid of hours and making it minutes by multiplying by 1/60? But then that'll tell me how fast it's going in minutes, and then I can say, hey, times 1 minute. Because that's, if it was 2 minutes, I'd say times 2 minutes. 5 minutes times 5 minutes. If I can figure out the speed in miles per minute and then say, hey, in 1 minute, how far do I go? And I get my 55/6 miles. Well, the minutes technically get canceled, see? So it's just miles, technically. But then with that distance, we can go ahead and use that and say, haha, we do know a distance, and once we know a distance, we can set up with trig and we can solve. This one was a little bit messier. The hard part was that we had to use the speed and the time to figure out how far the plane was going. This one? No.
Did you go over?
This one? Yes. Ooh, people in the back, did you hear what Emily just asked? I don't
No.
think so, and it was a really good answer. What'd you ask, Emily? Loud and clear.
Is it going to be on the test?
What, this one?
Yeah.
What'd I say?
No.
Not on the test.
Yay!
With speeds and distances. But what did I say would be on the test?
I am speed.
10 and 9 and 9.
Okay. So with that, boop, boop.
Greek or
Who's this dude?
Bearing?
This was what we didn't get to talk about, right?
Oh, we're talking about compasses.
Compass bearing.
In Minecraft.
No, no. Sophia, what do you know from WAP about the compass being invented?
It
What do you know from left?
was made in China. Everything else.
Like everything else.
And they used it to get.
Go WAP.
Very good, very good.
Okay, coming back.
I can't think of the spot.
So, but long story short, compasses have been around a lot longer than global positioning systems, right?
Not as long as Mr. Hart.
Okay. So, stop. North, south, east, west. I mean, that's a good old fashioned, if you guys know that we live on the west coast and all like New York and all that stuff's on the east coast. And then the North Pole, you go up, and then the South Pole, you go down. Hopefully we have the general north, south, east, west.
Never eat soggy waffles.
Thank you.
That's fine.
If you're west or east, though, because technically if you're on the east coast, if you travel far enough east, you're gonna be
You have to have a reference point, and that's the
Thank you, Emily.
struggle of physics.
I'm
No,
breaking my
no.
head.
Google Maps.
Now, do you guys see the problem over here? Where's the compass and the bearing and the, where does it get weird? Okay, we have like a knots, we have a speed thing. We don't like speed things. Oh, hey, if it's a speed thing, will this be on the test?
Yes.
No.
Not the speed thing. Remember I said that's a no. But could the compass bearing thing still be on? Yeah. So, okay, hold on. I just gave you the answer. I didn't mean to, but I accidentally did. This is weird, right? North 54 west.
Yes.
Now, if they didn't have directions like north and west, an old-fashioned, it would be called a compass bearing. If it was called a compass bearings always go from north. Think North Star, if you were in the middle of the ocean, North Star is like your reference point that you could try to use if you don't have any other instruments. You could try to find the North Star and then measure based on that. So compass bearing is always from north, but if they just say bearing, it doesn't even say bearing in this one, yeah it does, there we go. If it just says bearing and it gives you two different directions, they're actually telling you where to start and what direction to go in. So actually, once they, well, hold on, let's zoom in on this page really quickly and try to understand that northwest thing. Like I need the angle and I need to know where it's in my picture to even start to solve it. So hold on. What is that weird north 54 degrees west thing? It's still on Thanksgiving break too. You already checked it though, didn't you? Is it right in the hallway?
I think it was at the window. Because I'll be able to tell it's gender.
There are like 50 lockers open right now. Go fast.
That was,
35 degrees east.
that was,
You guys remember what I just said?
35.
Sorry. I meant as far as which one's which. This is my starting point. Start from, and this is my go towards. Does that make sense? Start from south. Okay. Go towards east. So all of this, like, hey, you always start on the positive x-axis, you always go up, that's out the window.
I know.
Because we're talking about compasses now, and it actually has to do with direction. So we're starting from south, and we're going towards east. What quadrant are we in?
4.
Yeah. You see it?
Everybody has to do the quadrants.
So you measure 35 degrees. Does that make sense? Starting from south, going towards east, we're rotating this direction towards east. Now, if we needed to set up a triangle here, we have to do 90 minus 35 and use some geometry knowledge, right?
Yes.
But that's okay. How about north 8 degrees west? What quadrant are we in?
Second to
Second. And how far away are we from the east-west line?
10.
Good. You guys tracking okay?
Yeah.
Start at north, go 80 degrees towards the west. We're 10 degrees from the east-west. Oh, sorry, did I say northeast? My
No.
east-west. North 45 degrees east. What quadrant? how far from the east-west line? 45. Now, if they just did a bearing of 45 degrees or a bearing of 80 degrees, and they didn't give you the different directions, up there, all it says is start from north, and so if they just said something like bearing of 80, you would have to take the object, and Emily, here you go, because you just said, like, well, wait a minute, how do you know if you're east or west? You have to take the object wherever it is, and then just make a little compass where it is. You say, okay, wherever you are, little object, north, south, east, west, from you, from where you are. And so you would start, if it didn't give you directions, you would start from the object's north, and then you always go clockwise. So if it just said bearing, you always start from north and you always go clockwise if it doesn't give you like a direction to head.
It just shows the graph and it's the same.
I don't think it, because then you realize there'd be so many different ways of saying it. Yeah, good question. Really good question. So let's figure out why this picture is so complicated. Bearings are kind of rough. They show back up in physics and they show back up in, calculus and non-calculus. A ship leaves port at noon. Where's the ship? Oh, he's way over there. I think that's his current location, though. Okay, so he leaves port at noon and heads due west. Can you guys tell on the picture, where is the part where he headed due west?
B.
Do you see it? So due west, that must be this part of the journey. Does that make sense? Okay, so here's my port. I can go ahead and put doop, 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 and he headed due west. Got it. At 20 knots or 20 nautical miles per hour. At 2 p.m., wait a minute, how long was he traveling for? 2 hours, and it's 20 nautical miles per hour. So how many miles? How'd they get this 40? Yeah, there you go. Okay, cool. So they filled in this 40 from multiplying by 2. At 2 p.m., the ship changes course to, do you remember how I said you have to take the object and its north? Do you see it? Where the ship was, I don't go back here to port and think about what the bearing was or what the compass was at port. Here's the ship right here. Somebody pulls out a compass. They're turning this direction. I know they have instruments, but still. It's this guy's north, this guy's south, this guy's east, this guy's west. So do you see how they were able to draw the correct picture of where the ship headed next? Ooh, that was horrible.
It hit it out.
But, do you see how they drew it? So from the object's north, then you went ahead and turned. And then we headed 54 degrees. Okay. And then it said, find the ship's bearing and distance from port of departure. At 3 p.m. Ooh, 3 p.m. How long was it going?
A long
3
time.
hours.
What? No. I mean, yeah, but we already did noon to 2. Then, okay, along this
1 hour.
part, yeah, just 1 hour. And if it was still going 20, which I don't know if it should have necessarily changed course at the same speed. But anyway, change course, went the same speed. This would be, okay, no wonder they put 20. It was from the problem itself. Now, guys, is the picture nice for you all? Yes. But did they technically need to label any of the picture?
No.
All the information is right here.
The info.
What are they asking? Find the ship. Where's the ship right now? Find the ship's bearing. Huh? Bearing, like this. And distance from, distance from. The port's way over there, right? So we're trying to figure out what this is. Distance from, here we go. Awkward arrow, but that's okay. We're trying to find the distance from the port and the bearing from the port. Do you guys see that word? From? Here's the struggle. Whose north am I supposed to be using for this bearing? That guy, the boat, or this guy, the port? From the wording in the question. Good. Do you guys agree?
Yes.
So the port's north. Why? From the port. So, long story short, the boat's way out there. Let's just say he broke down because of this turn that he did without slowing down. He broke down, he's whatever, and then sharks are coming, right? And they're like, help! And I'm guessing the only help is back here at the port. The port has to know, like, wait a minute, where are you? Let's assume GPS isn't a thing, but somehow radios are. Anyway, long story short, how can the port get to him from the port? So bearing, I want to know north, what angle, west. True? The boat's northwest, I know that. But how do I solve? What do you guys see? But the angle is totally not in any triangle, right? He's not in this triangle, which is not even a right triangle. He's not in... I could try to use like law of sines, law of cosines that we haven't learned yet. Or, couldn't I make a big old right triangle and say, hey, but what do I have to find? I know this guy is 40. What don't I know? I don't know that guy. I need to find this guy. I don't know this guy. Oh, stink. I have all kinds of stuff to find. But at the end of the day, I can't solve this problem until I figure out whoever this guy is. And until I figure out whoever this guy is. But if I can get my adjacent and my opposite, well, actually, technically, my adjacent and my opposite, then I can do Pythagorean theorem. And if I have two sides, I can find my angle. So what do I know? From all the clues, I know we went 20, and I know this is 54.
Ooh.
Okay. If I know 20 and 36, if I know two pieces of information, can't I find the third? And if I find the third, can't I use the Pythagorean theorem to find him? And if I know him, don't I have everything. So, long story short, what trig is going to help me if I have angle and hypotenuse and I need opposite?
All of it.
Oh, sine. So sine of 36 equals the big old puzzle. So my B is the guy I need over there for that big old triangle. Let me call this guy D. I didn't realize he had a name down here. My D is that guy. Well, my D is going to be easy because once I figure out B, I can do 20 squared is equal to B squared plus D squared. So D is going to equal the square root of. Has anybody, well, wait a minute. What mode do I need my calculator to be in for probably this entire homework? Yeah, degrees. You guys see it, right? So then we're in, on the test, are we maybe going to have to switch back and forth between degrees and radians?
Yes. Yes.
But if you see a degree mark, you know what mode to put it in, right?
Degree.
Good. So then if I get my B to be 11.755, do you guys know why I'm putting a dot and not?
Because it goes to infinity.
It keeps on going, and if I'm about to use it, why would I try to keep as much as possible? Yeah, once I start rounding, I start introducing error, right? So now I'm going to go ahead and square root my 11.755. I'm putting in everybody squared plus my... Oh, wait a minute. I have to subtract that from my hypotenuse, right? My bad. I need 20 squared minus b squared. So 20 squared, that's easy. That's 400 minus that dude. So I end up with 400 minus. You guys know you can just go up and steal a dude, right? Like the entire guy. And then I get 16.180333. Wait, we talked about needing B and needing D and everything is solved, but that's not actually the total answer. Aren't we supposed to be finding X marks the spot and then this bearing guy?
R.
Oh. This goes here. This goes here. works. Sometimes I don't know about your brain, but my brain works better when I have it all drawn out. How do I solve for x? Jane, this is yours. If I have one side and another side, how do I solve for the third side?
Oh, I thought it was
That one. So I can say that my distance,
Oh,
and this distance is hypotenuse, right guys?
Yeah, H.
Cool. So I can say distance is equal to the square root of 40 plus d squared plus b squared. And actually in my calculator, I just go steal those decimals and be like, sweet. So square root of 40 plus, who's the d guy? The 16. And then my b guy squared, which is the 11 guy. Do you guys realize you better have your calculator when doing this homework? Otherwise, life's going to be really sad. So how far did this guy need to keep traveling to go find this poor little stranded boat because they took the turn too fast?
You blow it up.
Nautical miles, so NM. He's not blowing it up. That's not exactly the point of a rescue. Anyway.
Get rid of the evidence that you killed them.
Oh dear. How do I find bearing?
Yes.
Wait, what kind of bearing is it going to be? Laurel asked earlier, are we ever going to have to see something and then have to label it? If you were to label this bearing, you could say from north and do it really awkwardly. Or couldn't you say he's just starting from north and going what direction?
West.
Yeah, that'd be the easiest way, right? If I was to do that, guys. So I want north, whatever my theta is, west. How do I find this dude?
Subtract from 90. Wait, no. Sine and cosine.
Okay, who do you want to do? Actually, we have all three sides. Do you want sine or cosine or tangent?
Let's do tan because
Okay.
he's gonna have attention.
I'm tan.
But why am I doing a tangent inverse? Where I have to do second tangent in my calculator? Why am I doing tangent inverse?
Because of equality.
Tangents work
Backwards.
backwards and say, give me the TOA ratio.
Give me the money. Give me the money.
Give me the ratio and I'll give you the angle, the degree. So who's my opposite for this dude? I need TOA. I need opposite over adjacent. Who's my opposite?
X.
No.
Wait, no.
16.
I'm trying to find theta. 40.
Nautical miles.
I need both. I need 16 and I need 40. Do you guys see it? Yeah, add those together. So I'm going to do, let's do like a big old fraction. Yes, I did 40 plus the 16 one.
56 point.
And then what's going to be the denominator?
40 plus 6.
My 11.75-ish. Divided by my 11-ish dude. Oh no, do you know what I just did? I accidentally put him in the numerator when he used to go in the denominator.
Oh, for a moment. Someone check the problem vibe real quick. Caitlin, check his vibe.
Got him.
Did you fail the object? Oh,
That actually, no, you can't.
Oh, yeah.
What do you guys think was the most complicated part of the problem? If you had to identify one. Maybe. But do you realize how they labeled all the complicated, they labeled a lot of the complicated stuff that you guys would have had to take time finding from the clues? And it was still complicated? One of the keys was knowing who's north, port's north. That's the compass bearing that I want. Or that's the bearing, I should say, that I want. You would have had to have done it another way. You would have had to do the compass bearing of like 360 minus this dude to go clockwise to get there. But he knows his north, just like, turn towards west. Yay, go. And you could go rest. Okay, bearings.
Oh.
And there's another dude? Okay, calm. Springs are the one thing that we didn't really talk about as far as simple harmonic motion. There's all kinds of stuff with waves and physics and all this application, kind of like logs and exponential. Do you remember how there was that application section that was like, man, this is used everywhere? for logs and exponentials. That's kind of what this section is too, but this time it's talking about trig and specifically towards the end with a simple harmonic, something bouncing on a spring or waves that are rippling, having to do with trig.
There are harmonics.
So, oh yeah. There's an application to that with the waves. Looking back at your guys' homework though, okay, you see there's an extra credit problem. You also see that I have attached some YouTube videos. One of them, is the one that you guys watched on last Friday. So if anyone was absent, that's the one that we watched then. And this is technically the nasty bearing problem, and I think the simple harmonic motion. But technically, what is your guys, I know you have a homework to do, but what is technically like at the very top of your list, hopefully, as far as making it through until finals?
The review.
The test on Wednesday. Then after that, we don't have any more tests or quizzes. So stop. Ready? Simple harmonic motion, the bouncing thing on a spring, not on the test. Cool, super applicable, harmonics and sound. It's a thing, but not on the test. Simple harmonic motion, which is why I'm basically skipping over it, even though it's good in physics. Bearing, barely. See what I did there? Barely on the test. Which means, remember that whole thing we did at the beginning of class, and I said no on this one and a yes on this one?
Yeah.
Make sure you're paying attention to the yes. The ones where you draw a simple picture, you solve a triangle with the Pythagorean theorem or with SOHCAHTOA. But don't get too caught up in like bearings are hard or simple harmonic motion. She gave us one of those, and I'm looking at your homework really fast, and I think if I have you ending at number 42, I don't think you have any simple harmonic motions, although there is a really cool like a buoy going on a wave and like shifting away from where it's supposed to be. But you guys don't even go that far. So, nice thing is, I don't need to cut out any problems because I've already cut out the ones that aren't important for the test. And I have, hold on, I have included a couple bearing ones, but don't get too stuck in them. Does that make sense? Don't get too stuck in them. Do your best. Bring me questions tomorrow. But here's what my advice is for you tomorrow. Bring your book to class if you have one, or grab one from me at the very beginning so we can get a workday started as soon as possible. Sound good? Okay. Finish attending 4.8 tonight. Have your calculator on you. Make sure it's in degree mode.
No.
If there's anything you guys need to catch up on, any corrections you need to turn in, etc.,